So this video lab is investigating properties of sound waves. To do that, we are going to use an app that allows this simple microphone and the app to act as an oscilloscope, which makes sound waves visible. It converts them into sine curves. So the instructions say to take a tuning fork and then put it in front of the microphone, and there we go. So if we zoom in here, what we have, that would be our 0 point. And then we go 1, 2, 3, 4, 5, 6 waveforms. If I get it just right. So then over here we go, number of cycles will be 6. The amplitude delta y is on the screen at 0.222. The delta t is also on the screen at 0.02368. Okay, and the frequency is 256. Next one. Whoa, a little bit louder. So we count waveforms. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I count right? One, 2, 3, 8, 9, 10, 11, 12. Ah! 14. And the frequency is 512. And the amplitude is 0.2749. And the delta t is 0.02749. Okay, the third one. Okay, I got kind of a... Okay, not bad. So there we have 1, 2, 3, 4, 5, 6, 7. Okay, so the wave cycles is 7. The amplitude is 0.544. The delta t is 0.02773. Okay, pause. Scratch that last one, I messed up. I did the same tuning fork twice. So this one is 384. And the waves is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, amplitude is 1.376, 0.0286. Pause. Okay, so if you zoom in here, you can see that if you take the number of cycles divided by the time, cycles per second, you get the calculated frequency, which you can see is pretty close. And then same thing here, 14 divided by this gives you 509, and then 11 divided by this, and we were particularly close here. Okay, so then the percent error you can figure out. And then the wavelength is velocity equals frequency times wavelength. So you take the velocity from the last experiment, and then you take the calculated frequency and take the velocity divided by the calculated frequency. Then down here you want to scroll back in the video and pause it and get thumbnail sketches of the different waves showing how the wavelength shortens with a higher frequency and how there's more waveforms. Okay. The next section is the diminishing of a wave. So with time, there's the waveform, and then so you want to draw that one, and then the same tuning fork is still vibrating, and then if you zoom in on the picture, so what changed? The amplitude is changing. So you can see the wavelength stays the same, but the amplitude is getting smaller. Okay, the next section, complex waveforms. So this is where I get to see how well I sing. So, I'm going to have to get my photographer to push that button. Oh my. All right, so you can see I don't have a very clear tone. It's kind of a gravelly voice, but if we count 1, 2, 3, 4, 5, 6 waves in 0.02354, 6 divided by 0.02354, and it should be 256. Hey, look at that. So it may be gravelly, but I'm in tune. All right. And then try it for a different tone. We'll skip over that. Now, this one is pretty cool. You get the tuning fork vibrating, and then you kind of do that, and then collect the data. Now zoom in closely, and you can see there's actually 3 versions of waveforms. You have the overall 256 hertz, then you have an octave higher in these jagged lines, and then if you look closely at the jagged lines, they're jagged also. So there's actually 3 octaves of sounds there. Okay, the next section. Beats. Okay, cross your fingers. This is tricky. So I'm going to need my photographer again to push the button. So can we multitask? Go ahead. One more. Again. Pause. Okay, so we unpaused it and we tried it without the background noise. We used the tuning forks 256 and 384. You subtract those two, you get 128 beats. Then we did it without the background noise and got this beat pattern. And you can see the constructive interference, destructive interference, constructive interference, destructive interference. Okay, so we have 1, 2, 3 beats in that delta T. So if you come over here to the data table, the two measured frequencies on the tuning fork, so we get 128 beats. The time that it took for 3 cycles was 127.99. Pretty close. Nice. Okay, now the last part is just kind of for fun. So we're just going to make random noises. I'm going to growl. Grrr. And then I'm going to buzz. Buzz. Okay. There's your random noises. So go ahead and go back and pause them and then draw them on the video and write what it is on the side. And then you should be able to answer the conclusion questions at the end. Have fun. See you next time.